Okay, more vectors. Vector algebra in 2 dimensions. Let's continue our work. So let's start with an example. We've got vectors a and b listed as such, and we're going to find a and b in component form. This component form is what you see here. That's column vector. Column vector. Okay, the linear combination is the ijk, the linear combination of the unit vectors. That's when you see that wording, that's what they're after. But component form means column vector. Okay, so find a plus b in component form. Rightio. So that's so a plus b will be simply 1 plus 2 and 3 plus 2. So that will be 3, 5. Okay, not difficult. Draw a diagram to represent a, b, and a plus b. So out comes my ruler. A is going to be 1, 3. So if I'm going to, perhaps I'm going to start from about here. I'm going to go 1 across and 3 up. 1 across. So I want to go 1 across and 1, 2, 3 up. So I want to head up to that sort of zone there. And I'll line that up. And that'll do. That'll be my A. My B, and I'm going to do A plus B. So B is 2, 2. I'm going to draw that in another spot. I'm going to go for B from here to here, 2, 2. Ruler comes out. And there I go. So that's my vector B. Going in that direction, let's not forget, or I didn't arrow my A. Alright, so if I'm going to do A plus B, then this B here has to move onto the end of my A, like so. That's all a bit sort of congested, isn't it? So, might move him back. In fact, let's move the A. So let's move the A across to the B, like so. Okay, so now I've got A plus B is going to be the beginning of A, or the initial point of A, to the destination point of B. Is it destination point? Terminal point. Okay, get out my pencil and construct that vector there. And that vector is my A plus B. And it should be 3, 5. So let's check that. 1, 2, 3. 1, 2, 3, 4, 5. So that looks good. 3, 5. That all matches up. Okay, we have A1, 2 in this example, and we're going to draw it. So let's start perhaps here. 1 across and 2 up. So out comes the ruler. And there's my 1, 2. I could probably do better than that. Okay, so that is A. Now we're asked to produce 2A. 3A, negative A, and negative 4A in component form, right? So 2A is going to be twice 1, 2, so that will be 2, 4. 3A is going to be 3, 6. Negative A is going to be negative 1, negative 2. And negative 4A is going to be negative 4, negative 8. Now we're going to draw each of these. So firstly, 2A is going to be 2, 4. So that's going to take me from this point here to 1, 2, 3, 4, this point here. And my ruler is going to help me out. There we go. I didn't arrow this. I'm continuing to forget my arrows. There we go. So that's this is 2a. So 3a. So you can see it's just we have a vector that's twice. Oh. If I just transpose a on there, then I get 2a being twice the distance of a. I'll just get a back, if I may, over here. Okay, so 3a is going to just be 3 times as long, so I'll just give myself a little space here. I'll start here, and I'll go 1, 2, 3 across, and 1, 2, 3, 4, 5, 6 up, and construct. Okay, so I'm going now 3a. Negative a, well, that's going to be -1, -2. So I'm just going in the opposite direction to a. Let's go with, all right, so if I'm starting here, I'm going -1, -2, ending up heading in the other direction, but with the same magnitude. So this guy here is -a, and -4a is going to need the most space of all, and he's going from, say, this position here to 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, all the way down to there, and connect. In that direction, -4a. Draw a diagram showing that the geometric and analytic, so geometric being what I've just drawn, the analytic being the component form vectors, that they're consistent. So we can see that they match up quite nicely. It's time to now do exercise 11D, and I'll see you in the Zoom.